All right, guys, what's up? Mr. Rushka here. So what I want to do today is I want you guys to just be able to practice finding using the unit circle to find trig values of angles that are bigger that are bigger than 90 degrees. Okay, so basically my goal for today is for you guys to be able to do, there's 12, don't worry about the ones I crossed off, but my goal is to have you guys be able to do find these 12 trig values, okay, on your own, okay? And I'm going to help you guys. I'm going to go through a few examples here. So I set a 45-minute timer for this video. I don't think it's going to be 45 minutes or anywhere near there. But that's my limit. That's my absolute limit. These are pretty good notes I found online. Oh, I want you guys to do these too. Oh, sorry. Okay. These are pretty good notes I found. Okay. So let's get started. So I did a lot today, like deriving where the unit circle comes from. But I don't think I did a good job showing you guys like how to actually do some of these problems I'm going to give you. So yeah, so let's talk about finding the sine of 210 degrees. And these notes right here are actually great. There's 5 steps, right? Draw your angle in your standard position, okay? So here, standard position means you start at 0 degrees, which is on the positive x-axis, okay? 90 is on the top, 180 is on the left, 270 is at the bottom, okay? You go around the circle 210 degrees, okay? And that's your angle in standard position, okay? Your reference angle then, you find by like drawing the rest of that triangle. The reference angle is going to be the angle that's right here, okay? So in this case, it's going to be 210 degrees minus 180, the angle between 210 degrees and 180 degrees. So it's going to be 30 degrees right here, okay? 30 degrees, okay? All right, that's the reference angle. And then you're going to use your corresponding special right triangle. So here you're going to use your 30, 60, 90 triangle, okay? So you have to be able to draw those in, okay? You're going to use the 30, 60, 90 triangle to find, what was it, sine? The sine of 30 degrees, okay? Sine, okay, think SOHCAHTOA, SOHCAHTOA, okay? SOHCAHTOA. So sine is opposite. So here's my angle, 30 degrees. Oh, gosh. Here's my angle, 30 degrees. That looks terrible. Okay. Third time's the charm. Here's my angle, 30 degrees. Okay. So sine is going to be the length of the side opposite 30 degrees. 1 over the hypotenuse of the triangle, which is 2. Okay. So the sine of 210 degrees is going to be equal to 1/2. Now there's one more thing. We got to make sure, we have to ask ourselves, is this a positive 1/2 or a negative 1/2? So what I've got to do is I've got to go back to my standard position, okay? All right. So this blue line right here, right? So 30 degrees is my reference angle. The actual angle whose sine I'm trying to find is 210. Okay. I just use the reference angle because I use the reference angle to reference which triangle, okay, to get that initial value, okay? Okay, my angle is in quadrant 3. My 210 degree angle is in quadrant 3 when I draw it in standard position, okay? Let's remember, sexy, tiger, cat, okay? So in the third quadrant, only tangent. So for angles in the third quadrant, only their tangents are positive. Their sines and their cosines are negative. So the correct answer to this problem is I've just got to slap a negative in front of there. Then I'm done, okay? So the sine of 210 degrees is negative 1/2, okay? I wanted to teach this to you guys this way. Use the 5-step method to come up with answers to problems like this instead of having you guys just memorize a bunch of values. That's how I chose to do it. If that doesn't work with you, though, I'm fine with you guys memorizing. I can give you a unit circle handout, okay? So let me give you one more example. Tangent of 5 pi over 4. Let's do cotangent of 5 pi over 4, actually. So I'm going to go over here, okay? So find the cotangent of 5 pi over 4. Find the cotangent of 5 pi over 4, okay? So we want to start either, so start from sine, cosine, or tangent. So here we're going to start from tangent, okay? So we're actually going to find the tangent of 5 pi over 4, and then we're just going to flip it, okay? We're going to find the tangent of 5 pi over 4 and then just flip it to get that trig function they asked for, okay? So let's draw our coordinate axes. Okay, let's draw, okay? So my angles here, let's do radians. So 0 in standard position, 0 radians is to the right. On top is going to be 90 degrees or pi over 2 radians. You guys know how to convert those. On the left is going to be 180 degrees or pi radians. And on the bottom is going to be 270 degrees or 3 pi over 2 radians, okay? All right, and we want to do 5 pi over 4. So let's draw, right, that's step 1. Let's draw 5 pi over 4 in standard position, okay? So here's 0 radians. If we go counterclockwise, this brings us to pi over 2 radians. Keep going, we get to pi radians. 5 pi over 4, right? That's just 1/4 more than pi. So it's going to be our angle we're going to draw around here, okay? So this is about 5 pi over 4 radians, okay? All right, let's draw in this right triangle here. Okay, we want to find, I'll do this in green, we want to find our reference angle, which is going to be right here, okay? That's going to be the difference between that angle that was given in the problem and this pi, this angle of pi right here, right? The angle between pi, the left part of the x-axis, and my 5 pi over 4 angle, right? That's going to be 5 pi over 4 minus pi, which is going to be pi over 4. So this is, our reference angle is pi over 4, okay? So what we do with that is we draw our pi over 4, pi over 4, pi over 2 triangle, okay? You guys got to know how to do this. Okay, so that's what it looks like, okay? And we want what? We want the tangent. Well, we are eventually going to want the cotangent, but we're going to start by finding the tangent of that, okay? So the tangent of pi over 4, let's think about this. So, toa, okay? So the angle, the side opposite pi over 4 has a length of 1. So tan pi over 4 equals 1 over, and then the side adjacent pi over 4 is 1. Okay, so tan pi over 4 is 1. So what we're going to do here then, for the angle given in the problem, we know that tan 5 pi over 4 is going to be equal to 1. We don't know if that's going to be positive or negative, though, so we have to check, okay? So let's fill this in. Sexy tiger cat, okay? So we're in the third quadrant. We've got a T here. What this T means is that for angles like 5 pi over 4 that have their terminal side, for angles in the third quadrant, their tangents and only their tangents are positive, okay? So tan 5 pi over 4 is indeed going to be just a positive 1, okay? What's cotangent then? How do we find the cotangent? Well, we just take the tangent and flip it. So that's technically just 1 over 1, which is just 1, okay? Done with that problem, okay? Cool, good stuff. All right, so that's how you do these, okay? So let's go over to here. All right. So there's nice notes right here. So for homework, guys, why don't we find all of these, okay? Let's find all of these. And I can make an answer key to it as well. So I'll make an answer key to this. And then let's talk about how to find quadrantal angles. Quadrantal means quadrantal angles. Those are angles that are on the axes. Angles on the axes. What do I mean by that? Okay, so let me draw some coordinate axes, okay? Okay, let's draw in our quadrantal. So this is 0 degrees or 0 radians. It's also 360 degrees or 2 pi radians. Up top here is 90 degrees or pi over 2 radians. Here on the left is 180 degrees or pi radians. And on the bottom is 270 degrees or 3 pi over 2 radians. Okay, so we've got these are our 4 what we call quadrantal angles. Okay, so all of these angles they're asking for inside our parentheses, don't worry about the negative ones. Actually, we haven't talked about negative angles yet. They're not too bad at all, but we just haven't talked about them. All these angles, right, 0 degrees, pi, 90 degrees, all of them are going to be on one of the axes. Okay, so let's draw. Here's how you find those sines and cosines. Okay, recall today. Come on. Trying to make it like give me that perfect circle. There we go. Okay, so recall today, right? If you have an angle, right? So let's say here's a 0 degree angle. So 0 degree angle, I actually just draw right here. Okay, it's point right there on the crust. Okay, remember I told you guys that x equals cosine theta, y equals sine theta, and tangent of theta equals x over y, or just sine theta over cosine theta. Okay, so right here, let's write down the coordinates of this point that I just put on the crust of the circle. Okay, it's a unit circle, so it has radius 1. Okay, I went to the right 1. Okay, I'm on the positive x-axis. I went right 1, up 0. So these coordinates are 1, 0. Okay, this is going to be my cosine of 0 degrees. This is going to be my sine of 0 degrees. Okay, so cosine 0 degrees equals 1. Sine of 0 degrees equals 0. Okay, so over here, the answer to this first one, cosine of 0 degrees equals 1. Okay, so that's the answer to that one. Okay, and then I'm just going to plot these other 4 points. Okay, so this point is 0, 1. This point on the left here is -1, 0. This point down here is 0, -1. Okay, so there you go. Then you can fill in the blanks knowing that x equals cosine theta, y equals sine theta, and tan theta equals x over y, or sine theta over cosine theta. Okay, so that's how you do these. I'll post an answer key. So for homework, just do numbers 1. Do all the problems that aren't crossed out. Okay, do all the problems that aren't crossed out for homework. Okay, you can do them on your iPad. Don't worry about printing it out. I'm just going to check that you have it done. Okay, you guys got to work with me. I know this stuff is hard because it's new. Okay, once you get the hang of it, once you get it down cold, we'll be fine. Okay, once you know it cold, we'll be fine. So do all the ones I haven't crossed off. I'll make an answer key and post it. Okay, you guys take care.